I'm Mark, or Sparky, according to this thing. Welcome to Basic Electronics for Cosplay. I've been doing custom electronics for about 10 years for medical research.
Can you turn it up slightly?
Oh, yeah, sorry.
I'm not doing it.
Any better?
Yes.
Yeah? Okay, fantastic. I'll try to avoid the feedback. Yeah, how to light up your life without setting yourself on fire. I decided to do this panel after I heard a few people talking about people making questionable cosplay decisions, mostly involving things like motorcycle batteries. Not the safest choice.
But it's so much fun.
Oh, it's so much fun. The third-degree burns are particularly fun. I'll try not to bore anyone. There is some math. Sorry. Yeah, I know. I'll keep it to a minimum, I promise. I don't know how many people there are here, but there are a few handouts. Yes, they're not pretty, they're technical. I'm sorry, it's mostly stuff so you don't have to remember it.
It's fun.
If you don't get a handout, I will put the original document on the webpage, either Facebook or the forum. It'll be available. Okay. The boring bit. Basically, 3 sets of math. All very simple. It's just divides and times. VIR. Very simple. Voltage, current, resistance. I don't know why they use I for current when it's measured in amps. It's daft, but I blame the French. Are there any French here? No? Good, because you're not changing anything now. Not at this day. PVI, that's just power in watts, is voltage times current. The triangles are great. You can rotate the equations. V is I times R, R is V over I is V over R. It's simple. You just have to remember it. Yeah, exactly. It's basic science class stuff. And the bottom one there, under all of it, available current is capacity over 20. I'll explain it all, trust me. This is just to get it in your heads to begin with. Volts, current, you've probably heard of them, but I'll go into a bit more detail on them. Volts. It's basically, if you think of water, it's like water pressure. The more you've got, the more, well, the greater distance water can go, the more it can get to do. Current is more like quantity of water. The more you've got, the more work you can do. Volts gets it there, current does the work. Resistance, it's like a tap. You turn the tap down, apply a lot of resistance, you get less electricity through, so things don't catch fire, burn out, explode. Does happen. And it's not a problem. If it does happen and you're doing it as a practice, something will go, you release the mysterious blue smoke, they won't work anymore. This is fine, it's fine. It happens as long as it's not your last component. Then you're buggered. But it happens. LEDs, they stink as well. If you pop an LED inside a box, it will stink and it will last for a long time. It's not harmless, not harmful or anything. I remember snorting it, but...
If you do snort it, please put the video on the internet so we can all laugh at you.
Yeah, I don't do snufflings. That's what she said. Power. It's good old-fashioned James Watt steam engine. It's like a 60-watt light bulb. It is unsurprisingly 60 watts of power. 240 volts times a few hundred milliamps. That times that equals watts. V times I equals power. Battery capacity. On every battery you buy, or not every battery you buy, but most batteries, there will be something that says a number AH, or just AH or MAH. Milliamp hours, amp hours. Remember that equation at the beginning, capacity over 20? Basically, batteries are designed to run for a certain amount of time. The company who makes them to run for about 20 hours. So what you do is you take the total capacity, say 1,000 milliamp hours, 1,000 thousandths of an amp for an hour, divide it by 20, which I'm not going to do it in my head in front of a room full of people, but let's say 100, actually that's 50. 50, you can draw 50 milliamps from the battery per hour for 20 hours. So if you've got a cosplay with 10 LEDs on it, and you want it to run for the duration of Expo, 3 days, 8 hours a day, let's say, you can work out how much battery power you need, or how many batteries you need, or what size of pack you need. Nothing worse than plugging something in, and then 3 hours in, your lights go dead. Very bad. I don't know how many people here were at Zelly's wedding on Thursday. 1, 2, we've got a few people here. We built them a little box that plays the Mario power-up noise when you press the button on top. Fair, it's simple enough. That uses a little PP3 9-volt power pack battery. They don't have a lot of power in. They've got like 300 milliamp hours. Tiny amount. That would run for a few hours. We had to only put the battery in just before. Yet, because it's 9 volts, it keeps things simple. But the small amount of juice means you can't run it for very long. So, while if you've got a project that you think will take 9 volts, yes, it's tempting to put a PP3 on there. Not a good idea. And I've probably jumped way ahead of the presentation now, but it's simple. It's circuits. Everything flows in a loop. You start with power, you go through everything you want to do, you come back to the power. If you don't connect at both ends, you're going to break somewhere in the middle, your electronics won't work. There is something you've probably heard of called a short circuit. I'm not going to talk about the 80s movie here, cool as it was. That basically just means somewhere your circuit has gotten connected between 2 points that aren't supposed to be connected. It cuts out a whole section. If that's just over one LED or one light or one buzzer or something like that, that's fine. It doesn't matter. You've lost one light, you find where the connection is, easy. It's very easy to do if you're soldering things close together. Not a problem. The problem is when you connect one end of the battery directly to the other end of the battery. I'll cover it in a minute, but suffice it to say, it's bad. Don't do it. Serial versus power. You've probably seen this in science class. It is basic. A serial circuit is one that goes from the battery to one component, next component, back to the beginning. The other one, the power goes to all the components at once. That one, that serial circuit, it's nice and simple, but it's not so good for cosplay, it's not so good for LEDs and things like that. I'll get into that in a minute. So if I just say the parallel circuit, that's what you want. There should be an example in the handouts. I'm sorry if you didn't get one, I'll put it up. You should always, if you're building light circuits, if possible, try to do them as parallel circuits. It saves more bother. I'll get into it. This is complicating that diagram a little bit. What we've done is we've removed the nice friendly batteries and things and got all those scary symbols. Basically, you've got a battery. That's all it looks like, a bunch of long and straight lines. It's not too complicated. And then you've got the lights, LEDs in this case, which I'm guessing most people are going to be using for their cosplays. Just because they're cheap, they're easy, they're efficient. It's not scary. It might be scary if you don't know the symbols and everything, but really it's simple. There's lots of stuff on the internet. There's a few things I can tell you about that. Batteries. You've got Duracells are your friends. Wherever possible, just buy little, normal, off-the-shelf, AA batteries. You can buy them anyway. Your cosplay fails halfway through, whatever you're doing, it's no problem. You send someone down the shop, which they sell them everywhere. Everywhere. You can buy AAs everywhere. And they don't really have any drawbacks. I mean, yeah, you have to recycle them and they only last for a certain amount of time and then you've got to throw them away, but it's not too bad. It's not too bad. Never use motorcycle batteries. Car batteries, things like that. They're not good. I'll get to it, but they're not good. Okay, various types of batteries. Most of the batteries you buy, they will have their chemistry written on the side. Alkaline, NiCad, nickel metal hydride, or NIMS. Nothing to do with rats, I checked. Nitrates. They're the old-fashioned rechargeables. You used to buy them everywhere. You use them as few times, and then they don't have much power in. You recharge them, and eventually they're dead. The trouble is, if you have a short circuit in your cosplay, wire comes loose, ends touch. If that happens, they dump all of their electricity as quickly as they can. And remember that one of the equations I showed you, I equals V over R. very simple. If you've got a wire that touches, the two ends of the battery touch, R becomes tiny. It's just a piece of wire. There is no resistance. It's like 1/10 of an ohm, or 1/100th of an ohm. Resistance is measured in ohms. I missed that bit, bad mark. V is still 1.5, the battery voltage. But most of these standard off-the-shelf batteries, 1.5 volts. 1.5 volts times 0.1 resistance, that's 15 amps. You don't get 50 amps out of a wall socket. You know, that's a huge amount of energy. And the wires that you've just short-circuited, they are going to heat up. You do not want that inside a Cosplay. I mean, love this story. I had an old MP3 player, took 2 AA batteries. One summer, I had a pair in my pocket because they ran out quite fast. They got shorted on my keychain. I wondered why my leg was suddenly very, very hot. The actual plastic outer of the batteries had melted. I'm lucky I didn't get burned. Just don't use them. They're cheap, they're easy, don't use them. Lead acids. They have lead and acid in their names. One is melty, the other is burning. One's burny, one's heavy. I mean, examples. I've got an example in here somewhere. Yeah. These things. They're not car battery, but this is a sealed lead acid battery. That's 6 volts at 4 amp hours. So you could draw, you know, half an amp from that easily. Maybe a quarter amp for 20 amps. It's quite heavy. It's a brick. You throw that at someone who'd feel it, and you don't want that weighing down a nice, you know, costume you're using. And if you short circuit it, all hell is out on you inside your cosplay. Zinc carbon, lovely. They're a lot more common nowadays. They're cheap, they're easy, they're reliable. They're actually a little bit safer than normal batteries just because they don't give you much power at all. If all you want is one LED, they are the safest option. As a purist, I prefer the alkalines just because you get more power. Alkalines, awesome, but not rechargeable. Nickel metal hydrides, they're the more up-and-coming rechargeable batteries. If you buy most off-the-shelf rechargeable batteries now, they will say nickel metal hydride or NIM on them. They'll recharge forever, they've got a decent amount of power. They're reasonable, they don't have as much power as alkalines, so if you absolutely have to recharge, use those. Lithium polymers, that's what you get in laptops, stuff like that. They're much more popular nowadays. You can get them even in little pen cells with like 3 volts. There's a reason you shouldn't use those though. While they are attractive, light, they're small, compact, they're cheap, they're easy to get hold of. There is a reason you don't use them. This is why you don't use them. These guys are experimenting with an off-the-shelf, it's like using a toy car or something. They are doing a few covered possible. Imagine if you use this. There's a tiny little battery, easy. You could run a cosplay with a few lights on for ages. But then a little wire comes loose, touches each other. They've shorted it with car battery leads. This is the electric going round, building up. Heat is being generated. You can see the package is bulging a little bit as gases build up. It is very hot in there. Then you start getting a little bit of smoke. This is where you start to worry. Because smoke coming out of a cosplay, if you've got this in a backpack or something where you don't notice it, not good. Then this happens. Yeah, I'm not trying to terrify you or anything. Alkaline batteries, zinc carbons, absolutely safe. They will not do that. NiCads could go that way unless you really, really, really know what they're doing. And if you've come to basic electronics for cosplay, I'm guessing you don't use lithium polymer batteries or lithium batteries. They appear really good, but they are dangerous if you don't know what you're doing, so just stay away. LEDs, the lights, the flickering lights. I'm guessing which is what most of you want for cosplays. I saw a lovely display last night on the main stage. I'm sure a lot of you saw it at midnight. That's, these things can really work well. You can get so many different sizes. I mean, the little ones, they're like 3mm. You fit hundreds of those inside a cosplay. They don't use a lot of power. You got the bigger ones, sort of that red one there, 5mm. generic, you can buy them anywhere. You can probably go on eBay, buy 100 5mm LEDs for a tenner. Stick them everywhere. Brilliant. You've got giant ones, you've got square ones, there's one there with 3 legs. They've actually got ones that have 4 or 5 different LEDs inside one casing, which seems kind of odd because you only really want to, what you do is you mix the colours. You put power in on the different legs, you can mix it to any colour you want. You have change colour. Kind of fun. You can get them up to like 20mm across, often the big chrome bezels they used for indicators in factories and stuff like that, or you can get them down to tiny ones. There's a huge selection, it's great. I'd say go out and buy some, experiment with them. They're cheap. If you blow one up, bit of a smell for a while. Maybe do it outside. If you don't blow up, you've learned something. Yeah. They don't get hot as well. If you're using them in the way prescribed, they don't get hot, so you can have them right close to your skin. Be careful, but you can have them right close to your skin. You can have a lot of them. They won't make you extra hot. You do have to be careful. All LEDs come in different types. You've got different colours, you've got different powers, you've got different angles. They will throw out light at a different angle depending on how they're designed. I've got a little bit of display. Have the lights down. Okay. Basic blue LED. Nice, pretty, a little bit of light. The thing is, it's directional. It's got a lens on the front. Yeah, you see, I'm getting a huge amount of light on the ceiling. Woo. But if someone's looking at your cosplay from the side, they don't get as much light. But I point towards you guys, it's only really bright face on. Slightly more diffused. You can see that side on, but you're still getting a lot of light out the top and a big pattern on the ceiling. That's an ultra bright, 3mm ultra bright LED. Again, dirt cheap. You can buy them by the 100, easy to use. Now, that's a green one. It's got a wide angle on it, but it's quite dim. You would not be able to see that outside in sunshine. If you're doing a cosplay that is, you're playing walk around, say, outside Expo sunny day, not going to be so good. Or on the main stage of the masquerade in full view, full bright light spotlights, going to be hard to see. Just, remember that. Ultra bright, you always want to buy ultra bright LEDs, and make sure that you get ones with a diffused or a wide angle viewing area. If you're doing them inside, if you want to say do Iron Man's chest piece, which I have seen done very well, and the original was actually done with LEDs, a camera light. Make sure you don't actually just aim it straight out, or you'll end up with lots of little dots and it won't look right. Always use reflectors inside the thing and aim the light inwards, and then bounce it around, rather than just trying to put the lights going straight out. Again, that one's even worse for the viewing side on. Anything other than sort of straight at you get a great green light, but unfortunately, anywhere else, you can only see a very dim glow. Depends what you're after, really. You guys know what you want, but for realism's sake. Thank you. Lighting maestro. Ooh, oh God, I see. Also on there, the picture on the far right, that's electroluminescence. Did I bring the electroluminescence with me? I thought I did. Or did I take them off the costume last night and forget to put them in the bag? No, I brought them with me. Awesome. Electroluminescence. Yeah, EL stuff. Getting more common nowadays. Very popular on the Tron costumes, things like that. It's great stuff. This stuff's basically, nice backup, thank you. It's basically 3 or 4 layers of plastic with the right chemicals between them. You apply about 100 volts across, I know, that is scary. 100 volts, that's a lot of battery. But it's a very, very low current. The volts get stuff to move the current tells you how much it can do. What you can see there is you've got several layers. One terminal is connected to the glowing bit, one terminal is connected to the non-glowing bit. You've got 100 volts across the two. If you're going to use it as a basic piece, I would buy it like that, in a strip with a battery pack attached. Don't worry about trying to do your own power. Just, it works out cheaper, and just 100 volts is still 100 volts. You could get a nasty shock. Where they've done it, if you buy it from China, it's sealed. All the joints are sealed, you don't have to worry. If you want to cut it down, cut from the opposite end of the battery pack. You can just trim through it with normal scissors. It's just 2 layers separated by a thin plastic sheet. EL wire is essentially the same thing, only you've got thin core wire and then a glowing wire wrapped around it, so you just cut down. Try to make sure that the ends don't touch, because if the ends touch, you get short circuit. Yeah?
EL wires just the same as neon lights? Or?
No, neon lights are basically a gas inside a tube. You heat up both ends with an electric current, generates electrons. The gas then fluoresces. In the EL wire, you've got 2 wires, one wrapped around the other, and the electrons excite the chemicals inside the wire. You can't actually flex neon, it's hard, you've got the gas trapped in there. You can do some funny, clever stuff with it, but it's a different system, and EL wire is a lot safer, much safer. Lamps. You will see people still using tiny little filament lamps, like the stuff you would get in a torch or some sort of headlamp. You can use them. You can buy them, they're cheap. You get tiny ones the size of a grain of rice. They look cool, but they have their drawbacks. They use a lot more power, they get hot, and if they get sudden shock, they will break. The filament will break. I would recommend using LEDs. Always remember to use an LED with a resistor. You can buy LEDs that have resistors built into them, it makes your job so much easier. But the trouble is then you've got a box full of sorted resistors, you don't know which one does which. Does this one have that resistor in? Does that one? Or try this one, pop. If you want to buy the ones with resistors in, keep them clearly marked. You can get them. You can also get ones with little timer circuits in. You just connect up a resistor and a battery to an LED and it will blink quite happily for you. 1 second, roughly. Beautiful. Very simple if all you want is a blinking light. Data sheets are your friend. Whenever you buy something, whenever you find something online, whenever you try and get something off the internet, there should always be a data sheet with it. This will tell you everything about the component, how much power it draws, what angle the light comes out at, what frequency the light is. It'll tell you, is it far red, far green, is it ultraviolet, if you want ultraviolet. Get your hands on your data sheet. No matter what you're buying, get your hands on your data sheet. That way, keep it in a book, you can go back to it, it will give you every single... I've got there's a little computer chip one I found there. It tells you what all the pins do. It will tell you how to figure out which pin is which. It will give you, there's usually on components some sort of marking on them that will tell you this end is electric, this end is also electric, but the opposite end of that one. That was a bad explanation. It will tell you how to figure out which end you should be connected up to what. Also, there are 2 different types of components you want to watch out for. Regular through-hole or leaded, yeah, I know it sounds dirty, but and surface mount or SMT. You do not want to be using SMT at this level. SMT is basically a tiny little, you can see them there. That is the same chip, twice. The small one is surface mount. That's the stuff you'll find inside iPhones and computers. It's tiny, but you've got to really be either a master hand with a tiny point on your soldering iron, or you've got to have like an assembly factory or a hot air rework station. Doing that as an amateur is not easy. Get the great big chip and push it into whatever you're doing. It just makes things so much easier. I mean, it looks fair, they both look fairly small because they've got a match head next to them, but anyone can solder one of those as long as you haven't got some sort of problem with movement, shakes, anything like that. Don't do it when you're hungover. Otherwise you'll end up one great big blob of solder and nothing will work. Resistors. Kind of a boring topic, but important. You've got to have these in your electronics. There's a few exceptions. Everything I've said, I'm giving you the basics. There are exceptions everywhere, but for best practice basics, just stay with this stuff. You can work out how much you need. There's, in the handout, which will be on the forum page, there is how to work out the resistor you need for a particular LED. It reduces the amount of power that goes through so you don't get a pop, which you don't want. Down the bottom there, little symbols. They're all resistors. They're all different types of resistors. There's a basic one you can change yourself, a temperature sensitive one. I doubt you're going to need that, but you might be getting adventurous, you might be getting fancy. And a light dependent resistor, which can be, again, fancy if you want to be. One thing I've just remembered, going back to electroluminescence for a second, buy the brightest you can. They don't work so well in, again, full sunshine. I saw a chap who'd done an Iron Man chest piece using electroluminescence. It looks good, but if you go out in the light, if you're anything other than a dark room, you're not going to see it. Resistors, there's a little variable resistor there. You twiddle the top, it changes. Whatever resistor you want, they all come like that. Just very simple beads with wires sticking out the end. If you know what voltage you have, you know what current you have, you can work out what resistor you have. It's so simple, it's just that triangle again. That's how you tell what a resistor is. Print that out. It's available all over the internet, resistor color chart. Print it out. That will tell you exactly what your resistor is. You don't even need to measure it. You don't need a multimeter, you don't need anything. Print that out. I've got a, it says brown, black, red. Oh, 1 kilo resistor. I know that. It saves you so much time sorting through a box. Oh, you can get testers. I have one. It's somewhat easier than trying to squint and see, but easy enough to tell what a resistor is just by looking at it. Why? Again, boring subject unless you're doing cosplay and you really need this stuff. It comes in solid core, which is just a long piece of metal. It comes in braided, which is lots and lots of little wires twisted together. Pretty good stuff. I mean, braided stuff is if you want to flex it. If you want to flex wire, use braided. If you want something that's going to be in place, not moving, solid core wire is so much easier to work with. It takes a good bit of solder, it just plugs straight in, solder it on, less problems. It's measured in American wire gauge, standard wire gauge, which is the British version, and cross-sectional area. People are kind of getting away from the gauges now because they're imperial, and going over to the metric, which is cross-sectional area. But you'll still find a lot of stuff online in AWG, just because it's been so popular in America and so like that. The higher the gauge gets, the thinner the wire gets. I've got samples of stuff here, and you can kind of look at it later. This stuff is only a few times thicker than a human hair. You probably can't see it from here. It's a thread with an enamel coating. Oh, there you go. If you want to hide that in a costume, it's fantastic. The only trouble is you're going so thin, it can't carry a lot of juice. You put more than 800 milliamps through that, it's going to start being hot. You've all heard of hot wire cutters for things like polystyrene, where you just take like a fused wire and you put a battery on it and you can cut stuff. It's kind of like that. That will take enough to run most of a costume, but if you try and stick too much power through it, you will end up with a burn unless you insulate it well, and it's not good practice. You can get stuff even thinner. That's, I think, something like 30 or 32 gauge. It goes to like 40. 40 gauge is human wire hair thickness.
So it's the higher the gauge, the more they are.
Yeah, basically it's something to do with the more, it's like shotguns. The more wires you can get out of a given piece of metal, the thinner it is, the higher the gauge. Insulated around the insulator. That is insulated by having a thin enamel coating around it. Most wires are insulated by having a thick plastic coating on it. You can buy the stuff uninsulated. It's very useful if you're doing complex circuitry and you want to connect to a whole bunch of places at once. If you don't, it's so easy to get short circuits. You always want insulation on everything. You don't want electricity going, you don't want it to go particularly into you or other parts of the circuit. Insulation is very good. In case you sort of say, oh, 40 gauge wire, I want that, make sure it doesn't say uninsulated. That's magnet wire. If you look for magnet wire, that's what you'll find. It's used for wiring magnets, amazingly. never use mains cable. Some people, you've done a building job in your house and you've got like 20, 30 meters of mains cable left on. It's usually a huge, thick core copper. It's great for twisting into models and doing like clay molding around, but it's really difficult to get a good joint in electronics, and you just have so many problems. If anything is to do with mains, just steer clear of it. It's a lot safer. Cosplay, assemble! Soldering. You need a soldering iron, you need a stand, you don't want to leave them just laying on the table. They are hot. I've got little battery ones, 450 degrees C. You don't want it on your skin. Make sure you've got a proper stand. You jam it into the stand, it won't go anywhere, unless you're really, really unlucky. A tip cleaner. Soldering is dirty work, and I would recommend use the old-fashioned lead solder. You can buy this stuff everywhere still. It's not used in electronics much anymore because of the environmental concerns and the toxicity. You can still buy it, it's so much easier to use. It's not a problem for you guys, because I mean, as long as you don't lick your hands, or eat the solder, or inhale the fumes constantly. If you're only soldering one cosplay or two cosplays, it's fine. But it's so much easier, it flows better, it makes joints better, it's everything about it, and it doesn't rot the tip of your soldering iron. Silver solder does.
Don't forget to get between the fingers if you do decide to lick, though.
Oh yes, always lick between the fingers.
Get the
Yes.
flavour.
Yeah, it usually comes with a core of flux, which is like a resin that means it cleans the joint and means that it flows around the joint so it doesn't make any accidental connections. Just that's of spits as well. I do recommend using goggles, or at least making sure you're wearing glasses when you're doing soldering like that, because it's kind of like working in hot fat. You'll occasionally get a spit, you'll go, ow! And it won't be pleasant, but if it gets in your eyes, that's unpleasant in the extreme. Insulate all your joints. You've soldered together 50 LEDs, it's fantastic, it's in. You can get heat shrink tubing, wonderful stuff. You put it over the joint, you heat it with a hot air gun. I don't know if hair dryer will work, I've not tried it. Those guns used for cleaning paint, that's great. They're fantastic. Give it a few seconds, it shrinks down, grabs onto the joint. You don't have to worry about short circuits, cross wiring, breakages, things like that. It can be a little bit of pain if you then decided you've soldered things around the wrong way. You have to cut it off with a Stanley knife and a great deal of care. But use it, please. It's good stuff. Buy it by the 10-meter roll, buy it by the 100-meter roll. It's just so good. You can use electrical tape. I've seen people where they make a joint, they wrap it around electrical tape. You can, it's fiddly. When it gets hot, it can slip off, and you'll get a poor quality joint. You can do it if you can't get the heat shrink joint, or if you soldered it and then you realise you need to heat shrink it, but I'd use the heat shrink when you can. You can get these things called helping hands. It's basically a metal base with a bar on and two little crocodile clips. You clip in the things you want, solder them. Again, it's so much easier just because you're not trying to hold four things at once. You need to hold like the iron, solder, two things you want to solder. If you're trying to, you're going to end up burning something probably yourself. Use these little helping solder aids, please. Tin your wire. If you're using like braided wire, also if you're using solid core wire, tin them. It basically means you put a bit of solder on it just when the wire is sitting there doing nothing. It makes it so much easier to join them. The solder flows into the joint. All you have to do is heat it up, the solder flows again, and it'll make a joint. Otherwise, you're trying to pour solder into the joint, poking the stuff in, and things move, things separate. Also, liquid solder makes things slippery. It's amazing how slippery they get, and they slide apart. If you're soldering an LED or a chip or a transistor or something like that, you might decide to go that far. It's fine. Don't hold the soldering iron on for too long. They're all very sensitive to heat. 5 seconds is fine. Go much over 6, 7, 10 seconds, the heat's going to get into the component, wreck the interior. It'll look fine, but it won't ever light up or work again just because you've overheated it. Solid conductors, you remember I said solid core wire and braided core wire? Braided core, you can flex that around and do anything you want. Solid connectors, if you bend them, you bend your LED legs too much, they will break. It happens. So don't flex them. Get them into the position you want, leave them there. That's a fancy soldering station. You don't have to buy something that good. It's like 10 quid off the market will do. Get the tiniest tip you can. You want a fine tip. Those are nice though. I mean, I've got one of those. They're fantastic. But just if you're only doing it on a budget and you don't want to do this every day, all day, you can just use a mains one off the market. That's fine. Helping hands. Those are helping hands. You don't really need the magnifying glass, but if you're doing really things that can help, but I've never used it. Usually I just bring my eyes closer and make sure I'm wearing glasses. That is a breadboard. I know you could, doesn't look like you could cut bread on it, but you can. Basically, lots and lots of little holes. Some of them are joined together with metal tracks. You just poke the components into it when you're trying to assemble your circuit, work out what you want to do. Plug in the wire. You're not having to solder anything. You don't have to join anything permanently. Once you've built what you want, you just pull out the component and actually use it. Saves you time, saves you money, makes your whole life so much easier. You can change things, you can rotate things, anything. I'd recommend, there again, 2 or 3 quid in sales. You can get them almost anywhere that sells electronics. Hot air gun, wire, strippers, very good things.
Strippers are awesome.
Strippers are awesome. I need more.
Sadly, these are not the ones in lingerie.
Aww.
They're nice too.
Those ones I use. Very good from RS. A little bit pricey because I got the pro versions, but you stick the wire in the end. That's it. It will strip you a perfect centimetre of wire. It's so much easier than trying to do it with your pliers. You get close. Okay, my wire is now half the length it was when I started because I cut off so much by accident. Just a pair of strippers. They're £5. Not expensive. You get a lot of use out of it. Pliers, ordinary side cutter pliers, very important. Needle nose pliers, very important. They're just so good for bending things to the right shape and trimming things down, trimming things off. Multimeter, your friend. The best thing in the world. Yeah, you can't do electronics without all the rest of the stuff as well, but multimeters are wonderful. You put them between 2 points, they will tell you what the voltage is. Put them in the middle of a circuit, they'll tell you how much current's going through it. Put an LED in there, they will tell you which way round it has to be. LEDs have a minimum voltage. You have to get them over this voltage in order for them to run. Somewhere between about 1.6. Is it still working? 1.6.
No, it's not working.
Oh, it's
Same
not.
like from last time.
Damn you!
I bet where's that guy who done that?
Blue.
It's the same mic.
About 1.6 volts to 2 volts. If you have less than that, problem. Yeah.
Ooh, hello? Hey, I fixed it.
I'm fine, don't worry, I did it. 1.6 to 2 volts for LEDs. If you use just one battery, you won't get your LED coming on, not enough juice. You need 2-ish. Depends on what sort of LEDs you're using. 3 volts is usually your minimum for LEDs. I'm going right back to green ashes, this is halfway through the panel, I apologise. Yeah. About 3 volts is what you need. That's 2 AA batteries for powering LEDs to get over your minimum of 1.6 to 2 volts switch on voltage. It's why you want to do parallel circuits. I mentioned them. If you use a serial circuit, you get to your first LED, you lose 2 volts. You get your next LED, you lose 2 volts. You get your third, you've lost 2. That's 6 volts gone already. That means you need at least 6 volts to begin with. You want to do 100 LEDs, that's 100 LEDs, that's 200 volts. You don't want to be running 200 volts through your costume. You do it all in parallel, you only need 3 volts. 3 volts will activate all of your LEDs because they're all getting 3 volts at the same time. The voltage doesn't disappear, it's just spread out nicely. The other thing is batteries, they lose voltage over time. You plug your battery into your circuit, you've got 1.5 volts. Or, assume it's a AA, or a PP3, you've got 9 volts. Fantastic. 4 hours in, your 1.5 volt battery will have dropped to 1.4. then 1.3, then 1.2. By the time you get to your end of 20 hours that the battery's rated for, you'll be down to like 0.9 volts. If you want 6 volts for your first play, say I'll use 4 AAA batteries, that's 6 volts, 1.5 volts each. By the end of your cosplay, you'll be down to 4 volts. If you haven't designed for that, if you haven't said that's how many volts I can raise a minimum, your LED's going to die. Rechargeable batteries often start only 1.2 volts. You start, I've designed this using AAA batteries. I'm going to switch to rechargeables. You thought you had 6 volts, you've only got 5 volts to begin with. So that's why another thing, always use amper lines. They're a little bit more wasteful, but a little bit safer, and a little bit easier, and you get a bit more voltage to begin with. There's a chart in the handout, again, it'll be on the website, tells you the voltages and the capacities of all the batteries. Generally, rechargeables are a little lower. You can get some nice, clever lithium ones, but I'll point back to the video of the lithium battery. Not always such a good thing. Now, I think Matt's probably going to start giving me ugly looks in a minute because I'm going to be running into his panel. I already have. I'm sorry, Emperor.
Don't worry.
But yeah, just everyone be safe. Use standardized batteries. Don't be afraid to experiment. The parts are mostly really cheap now. You can buy them everywhere. eBay is great. I've put some stuff in the film, but yeah, components. You'll find stuff in the handout. It'll be on the website. Get some and fool around. I'm here for the rest of the con. If you have any questions, I'll try and answer them. I've probably left people with lots of questions. It's not as concise as I hoped it would be. But thank you for coming, and enjoy the rest of the convention.